You know the world you see all around you? Is it really what's there? In this explainer, we're going to dig into the pretty startling gap between what our senses tell us is real and what's actually out there. And trust me, that gap is way, way wider than you probably think.
So, I'll just ask you straight up. Are you sure you're seeing everything? I mean, it feels like we are, right? It feels like reality just kind of pours into our eyes, fully formed. But as we're about to find out, your brain might just be hiding a few things from you.
And to prove it, let's just dive right into one of the most famous psychological experiments of all time. It's one that shows a massive, massive blind spot in our perception.
Okay, so the setup is super simple. You watch a quick video clip, you see a bunch of people passing basketballs back and forth, and your only job is to count how many passes the players in the white shirts make. Seems easy enough, right? You're focused, you're counting, you're doing the task.
But then, here's the twist. After the video's over, the researchers ask a totally different question. They ask, hey, did you see the gorilla? And what's absolutely incredible is that about half the people, 50%, have no clue what they're talking about. A person in a full-on gorilla suit literally walked into the middle of the game, beat their chest, and walked right off, and they completely missed it.
So this whole phenomenon actually has a name. It's called inattentional blindness. And here's the key. It's not a problem with your eyes. It's actually a feature of how your brain's attention system works. When we really focus our mental energy on one thing, like counting those passes, our brain actively, it filters out other stuff, even if it's staring us right in the face. The gorilla was there, but your brain just decided, nope, not relevant to the mission.
So why? Why on earth would our brains be built like this? Why would they be so good at just deleting parts of reality? Well, the answer, it turns out, is all about evolution and what the brain's real priority is.
And here's the thing you got to understand about the brain. Its main job isn't to create some perfect, high-definition photograph of reality. I mean, that would be incredibly slow and take up a ton of energy. No. Its number one goal is just survival. And to survive, you need to make fast, good enough predictions that help you dodge danger and find your next meal. So you see, accuracy takes a backseat to just being useful.
This idea is just captured perfectly by the psychologist Dr. Sam Goldstein. He said, our minds evolved to survive, not to see the truth. Think about it. From an evolutionary point of view, a tiny misinterpretation that keeps you alive is a huge win. Being perfectly accurate but getting eaten, well, that's a total loss.
So this leads to this really fascinating idea called predictive processing. See, your brain isn't just sitting there passively soaking up information. It's an active prediction machine. First, it's constantly predicting what it's about to see. Then, it takes in the raw data from your senses. Then, it compares that data to its prediction. If something doesn't match up, it updates its internal model. But, and this is the kicker, if it does match, it often just fills in the blanks with what it expected to see. So what you experience as reality is really this constant negotiation between what's out there and your brain's best guess.
Okay, so our biological eyes are limited. They operate on these predictions and shortcuts. But what happens when we start to build new eyes with technology? We can start by just looking at how we've learned to engineer the one tiny part of reality our brains can see, visible light.
And you might want to prepare to be humbled here. The entire rainbow of colors we can see, every sunset, every painting, everything, it all makes up just 0.0035% of the entire electromagnetic spectrum. That is the tiny, tiny little window our brains get to look through.
But you know what? We've gotten ridiculously clever with that little sliver of reality. For instance, over at the Pantex plant, they use something called structured light to scan weapon parts and find microscopic flaws with a precision that's just inhuman. At Savannah River, scientists use spectroscopy, which reads these unique fingerprints of light from different elements to make sure materials are almost perfectly pure. And way up in orbit, our GPS satellites have detectors that are constantly watching for the specific flash of a nuclear detonation. It's a huge part of our global security.
Okay, so engineering light is one thing. But what about the things that are completely beyond our senses? Let's take a huge leap now. From seeing with light to detecting something totally invisible, ripples in the very fabric of reality itself.
We're talking about gravitational waves. Just like Einstein predicted, they aren't some form of energy traveling through space, they are a stretching and a squeezing of space. So when two massive black holes collide a billion light years away, the universe itself kind of jiggles, and that wave travels all the way to us.
And the hunt for these things, wow, it took a whole century. Einstein called it back in 1916. For decades, it was pure theory. Then in '74, astronomers found some indirect proof by watching two stars spiral toward each other, losing energy just like Einstein said they would. And finally, in 2015, the LIGO observatories actually felt space-time jiggle. They made the first direct detection ever.
So how in the world do you see something like that? Well, the wave has a really distinct signature. As it passes through something, it stretches it in one direction while squeezing it in the other, and then it reverses. It's this sort of cruciform or cross-shaped pattern that our detectors are designed to look for.
But the scale we're talking about is it's almost impossible to wrap your head around. The very first wave ever detected from those two colliding black holes, it changed the length of a 4-kilometer-long detector by a distance of just 1,000th the width of a single proton. That is the kind of mind-boggling sensitivity we've engineered. We can measure a distortion in reality that's smaller than a piece of an atom.
So let's pull these two big ideas together. On one hand, we have our biological brain, which builds this useful but pretty flawed version of reality. And on the other, we have our technology, which can detect the universe with just breathtaking precision.
And when you put them side by side, the contrast is just stark. Our perception, it's all about predictive guessing, built for speed, built for survival. Its scope is incredibly tiny, and it is totally prone to errors and illusions, like that invisible gorilla. But our technology? That's all about direct measurement. Its goal is pure accuracy. It lets us expand our senses into the truly invisible. And really, its only limits are our own ingenuity.
So what this really all means is that our default view of the world is just a guess, right? It's an evolutionary shortcut. But technology, that gives us the tools to peek behind the curtain, to measure ripples in space-time and count atoms with light. Which leaves us with one last, really fascinating question to think about. If our reality is a guess, and our tools reveal the invisible, what else is out there, right in front of us, that we just haven't learned how to see yet?